All right, question 4, here it comes. So, a ball rolling up a ramp with an initial velocity of 6 meters per second accelerated at negative 2 meters per second until it came to rest. How long was the ball rolling? So this one's kind of interesting. There's some hidden things in there, some dynamic stuff that's going on. Let's take a look and see what is happening. So we've got an initial velocity, it says, of 6 meters per second, and it accelerates at negative 2 meters per second. So think about that for just a second. Negative 2 meters per second. So that means it's slowing down 2 meters per second every second. That's pretty cool. And it says then that it comes to rest. Now, hopefully, at this point in your problem-solving career, you're getting a kind of that intuitive piece to look for those clues. But to come to rest, that means that the final velocity is going to be 0 meters per second, right? It's slowing down until it stops. Okay. So we know those things. And then they want to know, this one's kind of fun, you guys. They want to know how long the ball was rolling. So really, how long is it going for? It's go that we're looking for time. That's what we're trying to find. Okay, so we've got velocity, we've got acceleration, we're looking for time. How might we kind of approach this on the graph? Here's my inclination. Often, not always, but often on these problems, looking at a velocity versus time graph is key. If you're not sure which way to go, I would say the best way to start these problems is to look at that velocity graph. So a velocity versus time graph is going to, well, let's just kind of take a look here. So it's going to start up at 6 meters per second, and then it's going to come to rest. So we need to start at 0. We need to have 0 be kind of our minimum, right? And then 6 is going to be our max. So let's go ahead and count up by twos, kind of like we've been doing. So this is 1, and then 2, 3, 4, 5. There is my 6 meters per second. And my time, so here's the funny thing. I don't know what the time is, so I'm not exactly sure where to go. Let's go ahead and do it by ones, and we'll see what happens. Remember, we did this on another one where we're just kind of give it a guess. So there's 1, we'll say 2, 3, and we'll just see what happens. I'll keep going. 4, 5, just to kind of to get a sense of what's happening. Okay, so we're going to start up at 6 meters per second because that's where it starts, and it's accelerating at negative 2 meters per second squared. So that means for every second that goes by, it's decreasing 2 meters per second. So in that first second, it's going to decrease from 6 down to 4. In another second, it's going to go from 4 down to 2. And in that third second, then, we can actually just extrapolate this out. We can also use our straight edge. So get that straight edge out if you haven't already, to draw a line. That line will be your slope, right? And it's going to go from 0, 6 down through. I'm trying to get a nice straight line here with my straight edge. And it's going to, that was kind of an ugly straight edge, sorry about that. It's going to go through those points and it's going to cross the x-axis at 3 seconds. So as this thing slows down, it will find, or we will find, I should say, that it gets to 0 meters per second at 3 seconds. So bam, without even doing a whole lot of really deep figuring, you did a whole lot of physics. That's really great. So we find that it comes to rest at a time of 3 seconds. Nice job, you guys.